All right, good morning, everybody. My name is Chris Jones. I'm with University of Arizona Cooperative Extension in Gila County. And thank you for joining me. We have Dr. Michael Crimmins with us. We're going to be talking about the flooding event in the Globe Miami area in September. And thank you for so much for joining us today. You see, so here's our agenda. Thanks for joining us when you did. As I said, my name is Chris Jones. I'm your moderator. I'm the county extension agent for Gila County. And our topic today is the Globe Miami flooding event of September 2025. We're going to have a weather and climate overview with Dr. Michael Crimmins. He should go about a half hour. He said he's probably got a little more content than that, but we're going to still have some time for some question and answer discussion. Please put your questions into the chat. I'll also check the Q&A, of course. And as long as we can go into the noon hour, I think we'll do our best to try to answer everyone's questions and go forward here. Today we have Dr. Michael Crimmins, Professor and Extension Specialist of Climate Science from the Department of Environmental Science at the University of Arizona. Recognize that picture, Mike? Don't know that guy, huh? And please check out the chat box. I've got a survey. It's pretty short, just a few questions about what you learned today and any ideas that you may have for other webinars or the information you'd like to share with us. So with that, I'd like to hand it over to you, Mike, and you can take over the slides, and it's all yours.
Okay, quick check. Chris, you can see slide okay?
I can see the slide okay?
Okay.
Yeah, I believe we're ready to go.
Okay, great. All right. Thanks, Chris. Boy, that picture, that was a long time ago. That was a cleaned up younger me for sure. Thanks for having me, Chris. And so Chris asked me to pull this together maybe a month or two ago. And I know that this was a very impactful event. And I remember watching the weather that day down here in Tucson. And I thought I had a good idea of what happened. And once I started digging into this event, it's a pretty complex event. And so we're gonna try to go slow today, um, and I'm gonna try to dial it in, make sure I get the right speed. But we'll have lots of times for questions too, and I can go back over slides that they don't make. There's a lot of content here, and I want to make sure everybody's getting everything they want out of this. Okay, so we're going to talk about the devastating flash flooding event that occurred across both Globe and Miami on the 25th and 26th of 2025. The most impactful event was on the second day and the 26th, but it really was a 2-day event. And it was pretty unusual to have multiple rounds of thunderstorms over multiple days. We don't tend to have that very often in Arizona. And the heaviest storms, I said, dropped several inches of rain. So the intense flash flooding that really hit the Globe area was on the late day of the 26th towards 5 or 6 p.m. And that flash flooding quickly emerged through the downtown area and caused widespread property damage and several fatalities as well. So we're going to talk about the meteorology and the climatology of this event. So lots of news coverage. It hit the national news as well. And I'm sure you're still all dealing with cleanup. And the pictures are pretty remarkable and horrifying in a lot of respects, just the widespread devastation that hit the downtown areas. So we're going to look at a lot of different data products. This is the first one I'm going to pull up. This is just sort of a snapshot looking at the 2 different days. And so this is a radar and gauge derived estimate of precipitation. So these little squares here are estimates in each square using both radar and then gauge corrections on the ground to try to figure out in each of those boxes how much precipitation fell. And these will be over 24-hour periods. So on that first day, the flooding that hit Miami, you can see these 2 cells right here were about almost 2 inches. And so this is the 5 a.m. of the 25th to the 5 a.m. of the 26th precip estimate. And so you can see it's a little bit. So Globe is right here over to Globe Miami, and this is top of the world down the road here. And so a little bit off to the northeast of Globe, more centered over Miami. And then we look down here, we see more widespread higher amounts of precipitation on the 26th, on the second round of storms, which we'll see later. There's actually maybe 4 rounds of storms that occurred from the morning hours all the way into the final flash flooding event that was in the late part of the day. But you can see here some really large amounts of 24-hour totals. And as we'll talk about later, much of that came in a short burst over the globe area in the late day on the 26th. Okay, so I want to just get some concepts here so I can try to tell the story from this meteorological and climatological perspective. And one thing too is that that's the focus today is on the meteorology and climatology. We're not going to really talk about hydrology or post-fire effects or watersheds. You're going to have speakers coming up, and Chris can maybe talk about at the end that will kind of stitch that part of it together. So I wanted to just, we'll put a pin on that and recognize that that's another part of the story when we talk about how the flash flooding emerged across the area. So in the meteorology basics, when we're thinking about extreme precipitation events, so just the most basic meteorology part of it is obvious, is of course we need moisture. So we have to have moisture advected and moved into the region. And so Arizona being the Southwest, we're an arid region. So we're often moisture limited, so we're dealing with, and we'll show you a couple maps here, just sort of thinking about that is the background condition. But the timing of this event being in the late part of the monsoon is usually when that tropical air mass that is the transition into the monsoon is settled in. So we still have lots of tropical moisture hanging around the region typically. And we're also still have warm temperatures. And so warmer air can hold more moisture. So we haven't cooled off into the fall season yet. We are in sort of heading towards fall, and this technically was after the autumnal equinox, but we're still in that late part of the monsoon season. And so we can get a lot of really heavy precipitation events, and they're often related to tropical moisture sources with the East Pacific season really starting to ramp up typically in September. And that was the case for this. So if you have moisture on the ground, that sticky air that you feel during the monsoon, you got to get it up. And so that's how we produce precipitation. We have to lift that air up. And as it's lifted, the pressure decreases, the air expands. As it expands, it uses its energy to expand and then cools, and we get condensation. So we have to have that lift. And so these little cartoon diagrams over here show the real main basic mechanisms here of convection. The air itself is buoyant. It's warmer and less dense than surrounding air. So you get these parcels of air rise. That's the bubbling that looks like you see in thunderstorms. We can have where we mechanically force air up a mountain and it's cooled and it condenses and rains out. And then we can have frontal interactions. If you think about back east on the big flat Great Plains, if you have cold air coming out of Canada, it can actually wedge under the warm air and lift it up, and then that will be a frontal boundary. The interesting thing is that this event actually had a little bit of all of these elements, and that's really what makes Arizona weather so complicated. And seeing how these storms evolved is having convection, which we'll talk about, also where globe is located, and the mean flow of the air is coming up out of the low desert and is lifting up the Mogollon Rim and is lifting up around the mountain ranges. And so you're getting that element. And then the frontal aspect, not real strong frontal dynamics in this one, but when storms actually start to rain out, they make little cold fronts around them, and those are outflow boundaries. And so that cold air that's associated with the sinking air of the rain coming down is cold and starts to spread out and becomes little cold fronts, and that will initiate the propagation of new thunderstorms. So that final thing we're going to talk a little bit about today too is that the way this event evolved is something called a transition event. And that's when you start to have the interaction of low pressure systems that are more fall-like interacting with the moisture that you have of the summer. And that's not uncommon in September. And so that will create organized storms that move in common directions and have some shear and some more structure to it, which we don't see in July or August very often. Okay, so just some of the data here too that you may be seeing on your phone as you're paying attention to the weather, but also we're going to talk about today. I just want everybody to have a sense of where do we get all this information. So this is the NOAA weather surveillance radar, the 88D Doppler network. And so this is the coverage here. And so in Arizona, if you can see my cursor here, we've got 3 radars that provide pretty good coverage for most of the state. You can actually see there are some areas that are weak spots and holes where we can't see towards the ground. But Globe is covered by the Flagstaff, Phoenix, and Tucson radars. And this gives us coverage, pretty good coverage, about 3,000 feet above ground level, all the way up to several tens of thousands of feet. And this is it's a radar, so it sends out bursts of radio waves, and it actually has a dish in that golf ball that is spinning around, and it's sending out bursts of radio, and it's listening. So it's sending and listening, sending and listening. And as it does that, those scans and the returns give information about the hydrometeors, or the things that are in clouds, which can be snow, hail, and rain, and differentiations from that. And so you get things like radar reflectivity, which we're going to look at today. The Doppler effect gives an indication of the velocity of the particles going away from or towards the radar. The Doppler shifts that can emerge. And we also some new fancy upgrades that have occurred in the last decade or so is the dual polarization that can give a sense of the shape and the types of hydrometeors. And then it's also used in a continuous way to actually gauge the volume of water falling through a storm to give us estimates of precipitation. So if we don't have a gauge, it's not a perfect replacement for a rain gauge by any means, but in areas where we don't have gauges, we can get an estimate. And so we're going to be looking at some of that today as well. And then also really important in our monitoring network that NOAA runs is and this actually is happening across all the meteorological services across the world, are weather balloons or radiosondes. And so if you've ever seen one of these take off, they look about, I don't know, they're about 8 to 10 feet wide, little orange parachute. And the payload here is a battery operated with GPS and telemetry on it that's taking temperature, humidity, and air pressure measurements. And they're released twice a day. And our 2 sounding sites are Tucson at the office here on campus, at the Flagstaff office up in Bellevue, and then occasionally, and I'm not sure if there was a sounding, the Phoenix office will do soundings occasionally during the summertime to support monsoon operations. I couldn't find if there was a sounding for that particular day, but there may have been. So at least 2, sometimes 3, a little bit of coverage issues right now too, with NOAA staffing issues as well. But this is an important thing of sampling the atmosphere from the surface up, temperature and humidity. So we actually know how much moisture is in the air, and the temperature profile is going to tell us if those thunderstorms are going to blow up real fast or they're going to be kind of weak, and also if they're going to move in any particular direction. So this all gets ingested into models, and that's how we get all the information we're going to talk about today. Okay, so what I want to do is make a distinction with this particular event, is that it was sandwiched between the typical pattern we see in the summertime with the monsoon and the wintertime pattern, the fall to winter transition. And that's where I was making this term of the transition pattern. I want to show you the difference. And so we'll just have some real high level cartoon graphics that if you've seen me give any of my talks, this I think is really important to try to understand that. And so in the wintertime, and these are the weather systems that we're seeing actually move across the state this week and have been over the last several weeks, is it's associated with the jet stream, and the weather's coming out of the west, moving towards the east, and it's associated with low pressure systems at mid and low levels of the atmosphere. And so that kind of weather system is broad, it's energetic, it has its own ways of lifting large areas of air. And so that's where we get our broad winter storms, where it rains over large areas, kind of some frontal dynamics, orographic lift, and those kinds of things. And then this graphic right here is showing us on average during the December through March period where the moisture is. And so this is mid-level relative humidity, cooler, moist air to the north. We have usually a large lobe of dry air off the East Pacific. So in the wintertime, and this is exactly what's happening with the weather systems that are traversing right now, is that we keep having chances of rain, but they're retracted because we're actually in dry air, the weather's to the north. And so this is the wintertime pattern. And I want to make that distinction about what we see in the summertime here, is that in the summertime, we're not dealing with those jet stream dynamics or the lows coming out of the west very often. until the later part of the season. So in the core of the monsoon season, the wind shifts around from the south, and we're starting to get moisture out of the Gulf of California, out of northern Mexico. And this is usually a pretty weak flow of moisture out of the south, and it's enough in our hot, high sun environment to have those storms pop up over the mountains and kind of wander around, interact with each other, and produce heavy rain in locations. And they don't often move very quickly, and we can get heavy isolated flash flooding from that. This event was not that. It was actually a little bit of a combination of these elements working together. And so again, in that summertime environment, the moisture, the dry air is now shoved off to the north west, and we're dealing with tropical, subtropical moisture. Okay, so this season was weird, and I think you all know there that it was not a good monsoon overall, but and all the rain came at the end of September, and then it actually rained again in October and November and the early part of this month. And so we've actually had not much in the core of the monsoon, but now I've had some really weird late monsoon and fall precipitation, and it's all related actually to the same pattern we've seen. So this mid-level pattern of where the lows and the highs are is mapped out here. This is the average of all the daily weather maps from July 1st to September 30th. And so large high pressure system, as you'd expect during the monsoon season at the 15, 20,000 feet in the atmosphere, high centered over northern Mexico, a low off to the west coast here. Again, pretty normal, but pretty normal is not good enough in the monsoon in Arizona. It actually is to lock in and be really perfect to give us a really good monsoon. So this map off to the lower right here is showing us the differences from the long-term averages. And so there's a little bit of a tell here is that the high pressure system was a little extended off into the East Pacific, and there's a little weak spot right here. This white area right here means it's near average, and the atmosphere is warmed up so much is that low pressure systems actually show up as near average on these difference from average maps. But where these little white areas are, where there were little weaknesses or little upper level low pressure systems that were a little out of place. And so this right here, this little white area here was really the reason the monsoon was so poor from the early all the way into the middle part of, well, the late part of August. And then it shifted around a little bit, and it actually kind of started to help us rather than hurt us. So this low pressure system shoving the moisture off to the south and the high pressure system off to the south as well. And this pattern from July 1st to August 20th kind of tells a story, is that with having that low in its position and the extended and suppressed upper level high, we had a pretty strong continuous flow of drier than average air into the southwest from July 1st to August 20th. We just couldn't get it to rain kind of anywhere. And it was a weak monsoon basically after that point. But then subtle shift is that the East Pacific tropical season started to fire up in basically the beginning of September, and little subtle changes in that upper level flow. You can see here from the 21st through the 30th, big shift around from drier than average to much wetter than average. So these reds right here are much greater than average atmospheric moisture and something we call precipitable water. So it's the column. If you squeezed all that out in a column of air, you get the depth of water in that column. Okay, so now we're going to shift into actually looking at the event itself. So this hopefully will animate. There we go. And this is from September 25th in the morning through September 27th in the evening or early morning. And it's just going to click through here. And so this is the actual weather maps at 500 millibars, so 15 to 20,000 feet. And when we have dips south, these will be low pressure systems. And when we have, when it ridges like here, this is a little closed high pressure system. But what I really want to focus on here is this little area here, which is what was closed, and then it opens up upper level low pressure system. And the colors here are precipitable water and how unusually wet or dry that area is. And so reds indicate much above average precipitable water or atmospheric moisture. So this little low pressure system is starting to work its way down off the California coast and into Southern California and into Southern Arizona over that 2-day period where the flash flooding events occurred. This is Hurricane Narda off to the south here, which had a real strong plume here. And there was a previous tropical storm, Mario, which I do think was part of this excessive moisture that had kind of wandered up there, got trapped by the low, and then pulled back down through the southwest. So this is the big weather maker moving in to the southwest. So what I want to impress upon you is that this is not a monsoon thing at all. This is a low pressure system that's much more fall like moving into the area. And in late September, if you ever get something like this and there's tropical moisture around, you're going to end up having some kind of impactful event. Okay, so let's start with the 25th event. And this is the event that produced flash flooding in Miami first. And so this right here is the morning, or this is actually in the mid-afternoon. See, this is mid-afternoon. This is late morning, afternoon, early afternoon, upper level weather map. So this is the 500 millibar plot here. And this is showing us that that low is Central California, and ahead of the low is a little small ridge here, but the flow is starting to shift out of the south, and that would increase the moisture flow into the region. And so there are numerous, so we have these forecast offices, the Weather Service in Arizona with Flagstaff, Phoenix, and Tucson. And Phoenix is responsible for your forecast area and Globe in Miami. And so there's also the NOAA Weather Prediction Center, which is out in the East Coast, which has forecasters coordinating with the local forecast offices. But those forecasters of the Weather Prediction Center are looking all over the country, looking for places that have the potential for excessive rainfall, and will issue products that say this area has got some risk, and then do these things called mesoscale precipitation discussions. So in the morning, well, this is actually early afternoon, noting that there was this flow of moisture coming into the region, the lows off to the west, was saying, you know what, this is a risk area for isolated flash flooding. So there were eyes on it. Forecast offices were paying attention to what was going on. It wasn't enough to issue a flash flood watch or a any kind of severe thunderstorm watch because of the idea that was most likely going to be isolated, but the possibility of having 1 to 2 inches per hour of rain rates was already recognized. So that morning it was clear, lots of moisture had flowed into the region ahead of this there. That creates that instability on the mountains first. And then that approaching low is starting to create a broader environment for heavy rain. Okay, so this is the kind of the recapturing of the radar at 2 p.m. Over both Globe and Miami. And I'm going to just hit this animation of the event here, and we can kind of watch that the storms were off to the north. And then several of them just started to pop up and train a little bit, meaning that they rained and then one formed behind it and then moved back over the same area there. And let's see if I can get this to go again here. And this is a composite reflectivity from several of the radars working together to get that. And so you can really see, if we kind of look at Miami here, a cell pops up, very, very heavy reflectivities. They extend and then they happen again over this. This is from almost noon to about 2:30 p.m. And so this right here shows at 2 p.m. the radar echoes. These are local storm reports of flash flooding, and these numbers right here are reports of hail sizes. So there was 1-inch hail and 1/2-inch hail reported, as well as these flash flooding reports right over the Globe area. And you can see how it's sort of extended across the whole area. And again, associated with that increasing moisture and that low coming in. Okay, the next day things get much stickier as far as the weather situation. So they are increasingly more hazardous because of several factors. And so you already had heavy rain that previous day that was pretty isolated across the state and hitting Miami and then parts of the globe. But if so, you can see here, this map, same map, now 24 hours later, there's starting some blue colors here, which means the low has deepened, which means that it is actually a little bit more energetic. It's going to have cooler air aloft, which is going to allow for steeper lapse rates, meaning more convective energy for storms that do pop up. It's going to have stronger flow, and it's going to drag more moisture up into it. And so the Weather Prediction Center really took note of that the environment had really increased as far as the hazard with the upper level support now of lines flowing away from each other at higher altitudes, which is going to allow storms to get more organized and pull more broad scale ascent. Lots of moisture, lots of instability at lower levels. And these red contours are indicating something called convective available potential energy, and values over 1,500 or 2,000 are real uncommon in Arizona and indicate extremely unstable air that's going to associated with really strong updrafts and strong storms. And so you can see in their mesoscale discussion, they are noting that there's going to be rounds of storms and locally significant and life-threatening impacts will be possible because of the extent of and the conditions that are associated with that. So the storms formed in the morning and several rounds occurred across the state through the day, including it looked to me like Globe had 3 or 4 rounds of storms from the early morning hours into the final in the late part of the day. The Storm Prediction Center also was paying attention to this. This is in Norman, Oklahoma, and they're thinking about tornadoes, hail, and strong winds. And so their morning discussion was noting that this area had a higher risk for isolated severe hail and wind through the early afternoon, and to the point where they actually issued a severe thunderstorm watch in the early afternoon prior to the several rounds of storms that occurred later in the day. Okay, so this is, and I want to point out, hopefully you can see the link at the bottom here. The Phoenix Weather Service office did a really great write-up on the events that including the Globe event, but also the storm impacts that occurred across the valley down in Phoenix. So they're pretty widespread. So they have this animation on their website, and I just grabbed it from that. But I'm going to try to get it to get you associated with the beginning of the radar loop, and we'll kind of watch things progress here. And so it's getting to the end here, and it'll reset in just a second. Okay, this is through. Okay, so this is the morning. And if we look over here in Globe, some morning storms, late morning, a second round in early afternoon. And then as we look at this large scale cluster of thunderstorms right here, this is right there, was right around 5 or 6 p.m., which is the final round of storms that had the extremely heavy rain. So right over the Pinals and the whole corridor around Globe that produced the flash flooding. So this is the, let me throw up this, this here. All of these polygons here too are the different flash flood warnings and severe thunderstorm warnings that were issued through the day up until the point of the event. And then this right here is the radar at 6:35 p.m. right over Globe. So showing the kind of the peak of the intensity of the rain. And we'll throw on the animation down here. And so this is 1 o'clock. It's 2. Oh, you know what? I'm sorry. I think I have the wrong animation here. This is from the previous day on the 25th. I wonder if I have that somewhere else. Anyways, I will dig that up and put that in there. But you can see here that on this previous here, that the this was that final push right from basically 5 to 7 p.m. of that final round of storms there. I do have this animation, but I have the wrong one up. This is the 25th event there. Okay, so if we look at the total precipitation estimates then, so this would be, this is from the right up from the Phoenix Weather Service office here. You can see just the bullseye right here on the globe area of up over 2 to 2.25 inches, and the um, flood control gauge in globe showed this from basically 620 to 650, if I'm reading that time correctly. It was about 2 inches in about 30 minutes. And so looking that up, that's a between a 1 in 50 to 1 in 100 year type precipitation event over 30 minutes. And so that would be a 2% chance in any given year for 1 in 50, or 1% chance in any given year here. And the rise then was really very fast here from 0 stage feet to up over 6 feet in just a matter of 30 minutes or so. So that would be in the wall of water that would have come down Pinal Creek associated with this real intense rainfall rate that occurred. So if we look at the total precipitation for the 26 across the gauges that we can grab here, you can see 2.71 inches just outside of Globe, 2.26, just south of town, 2.36. Miami had 2.33. The peaks around here too, 2.36 and almost 3 inches just south. So, not just isolated to Globe, but across the whole region at the higher elevations as well. Lots of water was being put down, which was then going to flow downhill and into any creek and wash that was going to be associated with these particular watersheds. Okay, and I just wanted to point out here too is that this is all couched into a very strange year with exceptional drought occurring last winter through a dry monsoon to these events that occurred in September, October, and November. So the 90-day precipitation total for the globe gauge from August 25th to November 23rd was 12.32 inches. So that was just over a 90-day period, over 12 inches, and that would be 2.5 standard deviations above average. But if you extend that out, so that's just in the last 90 days, and that's including that event you had in September, but also some follow-up event. I know you had flash flooding again issues in October with another event, and then another heavy rain event earlier this month. So in the last 90 days, getting 12 inches of precipitation. But if you extend that out over the last year, you've had 16 inches of rain. So 12 of your 16 inches of rain you've gotten in the last 365 days came in basically the last 2 months. So that's an extreme way to get a total. And you're not even up to you're just slightly above your average right now, getting your annual totals right now. I couldn't find a plot for Globe, but just to kind of put that into context a little bit more, this is Apache Junction down the hill and did not get as much rain as you did, but you can see that the normal accumulation of precip since last January, and we're running into that to the end of this month, is very dry conditions. One event last March, basically nothing, April, May, June, into July, some precipitation later in August as we had that switch around. And then here are the events from late September, set a daily rainfall record for Apache Junction, again in October, and then the event later in November. And so this big step up is all occurring with that first flash flooding event and the last couple that we've seen. Okay, so just to wrap it up here is this is kind of the way I was trying to put it all back together in my head, was that the monsoon overall was shaped by this unusually and strong and persistent upper level trough along the West Coast. It's there many monsoons, but it's not usually as far inland and as far deep. And that shut down the early part of the monsoon. And the flow ahead of that is going to drag dry air into it. And it wasn't until we got to the burst in East Pacific tropical activity and a slight reorientation of that low that it all of a sudden opened up the floodgates of moisture into the Southwest in September. And then having that upper level low start to work its way down and into the Southwest on basically that week of the 20th and peaking with the 25th and 26th, really set up the dynamic. So you had all of the hallmarks of having monsoon moisture and a fall winter type storm moving into the area. And what needs to be unpacked a little bit more is how the watershed hydrology works around the globe area and the post-fire flooding impacts that can exacerbate when you have rainfall events of this type, can actually enhance the flows across the landscape. And so that'll be addressed in future presentations. And we always have to kind of put in the back of our mind is that climate change it's everywhere all the time now. And so it's the background condition for everything. And so as you have warmer air everywhere and we're evaporating more moisture, is that creates a more moist environment. So as we have these conditions that are unique and novel to the Southwest and in the late part of the fall, is that they will have more energy and moisture to work with as we move into the future. So thanks for entertaining all that information, and I'm happy to answer any questions if anybody has any.
All right. Mike, thank you. That was a serious deep dive into what happened. Thanks for giving us that background with the weather terminology and events to see how that comes together to make this an exceptional storm. So why don't we go ahead and close that screen there so we can pull that back up as needed.
Okay.
I want to thank our 30 or more people who joined us for today, and invite you to bring in some questions in the Q&A. I can see that's happening already. Also want to direct your attention to the chat box. I've got a short survey I'd like you to fill out before you go. So if you're going to take off or just have some time to do that, should take you 3-4 minutes max. And so here for the questions, a couple of questions. They're coming as anonymous. First is just a comment. They say, I think it is also important to note that by that time, Globe Miami had barely 2.5 inches of rain all year. Yeah, it had been amazingly dry. And they comment that I was there both days and the storm was very intense and extremely windy. And the other comment, actually, we have a question now. Do you think the lack of moisture / dryness of hydrophobic soils also may have caused the increased runoff potential for the area?
Yeah, I think it can. I think it can. I think that the combination, very, very dry soils and the types of soils can interact with heavy precipitation. I do think the post-fire element here too needs to be explored and thought about a little bit more. I think that's got to be part of the hydrophobicity of the soils. We also have to recognize too that these rainfall rates were extremely intense too. So it's probably healthy, good soils and watersheds would have a real trouble absorbing those rainfall rates. And so I do think it is a combination of all those things that enhance things though.
Your graph showing just how quickly the water rose at Beer Tree Crossing in a half an hour, that it went from 0 to 6 feet in a half an hour that was the experience. And it was just so sudden. It was just pretty horrific.
Yeah.
Okay. So next question, how likely is this to happen again in the near future?
Yeah, it's the weather prediction element. I think it was a unique combination of things that happened in the late part of the season, right? And so those types of end of monsoons they're not happening every year. So I don't think it's something that we can plan on happening every year. I think also too that these types of events are probably going to be more isolated to the tail end of the monsoon rather than the middle of winter. I think they would be less common in the middle. You can have very heavy rainfall events in the winter, and I know Globe has experienced them, but they're usually multi-day events that lead to rises that are much slower. So these flash flooding events, though, I do think are going to be a little bit more late monsoon and certainly not happening every year, but the risk is there. And the landscape tells the story when you see large boulders that are in odd places, that's usually a good tell that some kind of catastrophic flash flooding has happened at some point in the last 1,000 years or something like that.
next question. Would you say that this was a 100, 200, or 300-year flood event? So when they talk about those probabilities, what is it?
I don't know on that part of it. Those kind of recurrence intervals on the streams I never could quite find the right data or even interpret it well. The best I could find was on the recurrence interval for the precipitation rates. And so the best I could see out of the NOAA data that is from both measured data and model data was with that 2 inches in 30 minutes being a 1 in 50 to a 1 in 100 year type event.
Say that one more time.
So the
It
two
was,
inches that was observed at the flood control gauge for that location is most likely either a one, it's somewhere between a 1 in 50-year event or a 1 in 100-year event. So the average risk would be about 1 to 2% per year of seeing that kind of precipitation rate in 30 minutes.
wow. Well, I guess it did. And Mike, I got a few more questions here, but it was just occurring to me that we did have that flooding the week or two afterwards in early October. I felt like that was associated with a couple of hurricanes kind of coming together down off the coast of Mexico shortly afterwards. We didn't have the same type of debris along the creeks, and so we had some flooding, but it wasn't nearly as bad. Was that kind of still the same type of story?
So was it October, Chris? Was it you were talking about
Yeah, I
the?
think October
Yep.
10th, maybe.
Yep. It was same thing. It was
Okay.
active tropical storm activity, same kinds of lows coming in off of the Southern California, right off the West Coast, interacting with that tropical flow, and it was a repeat. It wasn't quite as energetic and extreme with the severe weather, but they certainly had the flooding associated with it as well.
Okay. And it seems like it's just that orographic lifting. It comes off the deserts, gets onto the Pinal Mountains. The south facing coast side doesn't necessarily get as much, but on our north side, we can just get a lot of water.
Yeah,
And
absolutely.
even in the valley rather than just on the peaks.
Yeah. Yep.
Okay. Okay, next question here. Um, can you provide some background on how the 1 inch year rainfall amounts are determined? Who is determining them? And are they going to be adjusted as a result to this event and climate change?
Yeah, it's a really good question. So there are some long-standing standard ways that are wildly imperfect, and they're usually from limited gauge data that actually has observations of precipitation intensities at short intervals. And then it's typically then using statistical models to try to figure out how on longer time periods, you're basically extrapolating how those events might occur in smoother distributions. You're fitting statistical curves to them, basically. And then across the landscape, you're trying to then estimate away from the gauges what those things look like. So it's not perfect, and there are some problems with it. And there's also the interpretation problem with it too, is that these recurrence intervals don't mean that once you have an event, you're good to go for like 100 years. They can happen repeatedly. They're
Right.
just based
Yeah.
on the statistical distribution of the observations. Climate change absolutely shifts those distributions over time, and there is active research on trying to figure out how to actually adjust those. I don't know on the official side if this event then will change that distribution. I have on the link, and I'll make sure I share these slides out. The source of where I pulled that from it's a standard official NOAA National Weather Service source that is used. But there are now private companies that are doing for risk assessment and insurance are developing their own types of estimations on flood risk.
Dynamic.
Yep.
Yeah. Okay. Don't know if you can answer this, but another question. Is this a similar event, a way to know to what happened to Globe in 1954 and 1994? I had a neighbor that said they remembered being as a young person and seeing cars floating down the street in 1954. Any,
I don't know. And I was this close, I ran out of time. I was this close to diving into that event because I saw pictures of the 54 event in some of your local newspapers. And I can't remember what time of the year, but if we knew what time of the year it occurred, it'd probably give us some indication. Could have been, if it was in the same time of year, it could have been similar. It could have been a tropical storm. Tropical storms usually are flooding events of record across the state. And I'm not sure what happened in 94, but that's certainly, we could dig into some of the weather records and look at some of the weather maps, put that together.
I recall 93 was a very wet winter. We had bad flooding in the Phoenix area, but that was more of a winter storm.
Yeah, that was Oak Creek Canyon flooded, Phoenix flooded, and that was atmospheric rivers in the middle of winter, which again, atmospheric rivers, similar dynamics, middle of winter, lots of orographic uplifting, and you can in that part of Arizona get isolated flash flooding. It's usually not, 6 foot rises and washes. It'll be over a period of days, and then you'll start to see everything swell up and
Yeah.
water flowing everywhere.
Okay, Melissa's just asking, will this be available by email following the webinar? Yes, it will, Melissa. And actually, we'll get this converted and put up to YouTube as quickly as we can and be on our website. And I'll share that out to everybody so we have this recording available. TC looks like he confirms a 1 in 100-year event. And Melissa asks again, if you had to guess, is this likely to happen again due to climate change, et cetera? I think we were just kind of covering that question already. So,
Yeah, it will happen again for sure. I just don't know when. If it's 1,000 years from now or if it's 20 years from now. I mean, it's the risk of living in complex environments like we have in the Southwest for sure.
your charts indicated some early signs building around California and Arizona. How much time is available to actually give warning that it may happen?
Um, yeah, so the environmental conditions were building for several days. It's knowing that you're going to have 2 inches in 30 minutes over a very specific small watershed in an urban area that's where weather prediction just isn't, we're not there yet. And hopefully I kind of told the story is that the broader weather enterprise from Weather Prediction Center, Storm Prediction Center recognized the risk. The local weather service offices did too, and were watching things. Flash flood warnings were going out. But I think recognizing that that cell was putting down water in that spot to then say that you're going to have that impact we're still not quite there yet. And that's where flood control networks, and we've got a lot of innovation to do now on trying to stitch a lot of that information together.
Yeah, from the graphs you were sharing, it looked like we had a 24-hour, warning over a very large area.
Yes, that's it. And so knowing like in that
Yeah,
spot, right? And the storms that were occurring through the day on Friday, I kept expecting that the next wave just wouldn't come because usually the atmosphere stabilizes, but that, 3, 4 rounds of storms with the final round being the strongest is what ended up happening on that Friday.
but still, as large as those footprints are, we got it in Globe, Miami, and it could have been somewhere else in that footprint. Is
Yeah, and having it two
that
days in
right?
a
Yeah.
row, right? I mean, the you had saturated soils, even being so dry. I don't know if they were saturated or not, but being so dry for that long, and then all of a sudden getting 2 inches in a location, there is now water that is kind of ponding and moving around in that, and then getting it multiple times the next day that's a really rare situation to have those stack up.
Yeah, yeah. And Jen is asking, do you have similar data from Globe Miami floods in 2021 or other years to compare the data from these flooding events we're discussing? So
Um,
2021 was after the Telegraph fire, those events
oh,
we had
okay.
shortly afterwards.
Yeah, we certainly could pull. I mean, the weather data with the radar gauge analysis and the local weather maps and those all could be certainly assembled.
Okay. All right. Um, Seems like questions have slowed down here. If anybody else has any other questions, we can share them. Oh, here we go. Our Gamero shares the flood of 1954 occurred in July.
That's
Was a
interesting.
summer
Yeah.
storm.
Yeah, I would
And
expect the dynamics would be a little bit different with that event if it was in July.
yeah. Okay. Well, this has been fascinating for me at least. I hope everybody else too. Looking at the participant list, everybody has hung on for the whole hour here, Mike. So that's great. I'm going to wind this down now unless I see another question pop up. Do want to refer you back to the webinar chat. Please see that short survey. Respond to that if you would for me. Gives me some information and going forward. I'm going to bring up one last slide here. To let you know what else we have on in the docket. Come on. Here we go. So if you can see that okay, our next webinar, we're going to have another webinar on Thursday, December 18 at 3 p.m. in the afternoon. Strange hour, but that's just the way my time frame works right now. Kelly Motlacroix, who is the watershed program manager for the USDA Toronto National Forest, will be talking on the same type of event, but we'll be focusing in on the watershed conditions. So what role does or doesn't watershed health play? So some of these questions about what's happened on the watershed, on the mountain, and what we have, will tie in with what we just presented here with the weather. So thank you so much. And let me take another look at the questions. A few more popped up because they can't get to the survey. I hate that. Let me see if I can get the survey to go now. I'll copy it again, put it down there again, and hopefully people can get into it. Because I thought I published it and put it to share. Well, everybody, thank you for your time today. Uh, Hopefully you can join us again on December 18 for our next webinar. And I hope you all have a good afternoon and have a great day. So thank you, and we'll sign off now. Bye-bye.